Okay, today our lesson is on solving absolute value inequalities. So the difference between yesterday and today, yesterday were equations with equal signs. Today are inequalities, which will have less than or greater than signs. First, we're going to sing a little song, and I'll explain the meaning in just a minute. But the song is here on the slide. Less is nest and more is or. It goes like this. Less is nest and more is or. Do da, do da. Less is nest and more is or. Oh, the do da day. Less is nest and more is or. Do da, do da. Less is nest and more is or. Oh, the do da day. So here's what it means. Less is nest is referring to the less than sign. When you have a less than sign, you know that the solution is going to have an end point, and all of the possible solutions are going to be in between 2 points, like you're making a nest for a bird. There's my lovely bird. And so this is what less looks like, a nest. 2 points that connect together. More is referring to the greater than sign. More is or, like the oars of a boat. So there was a boat right here, and these are their oars. It means that it's going to be greater than one number and less than another number, but the possible solutions are not what is in between the 2 points. It goes out from those 2 points. So with less than, you create a nest. With more, you create oars that go out like this. Less is nest and more is or. So let's see what that has to do with today's lesson. Okay, first of all, we're going to recognize up here there is a less than sign. So we know right off the bat that when we get to the solution, we're going to have 2 points, and the solution is going to be in between those 2 points, making a nest. Like yesterday, our first goal is to isolate or get the absolute value by itself on one side of the equation. So in this particular equation, we have the absolute value of x plus 3 is less than 12. So we have to move the 3 to the other side by subtracting 3 on both sides. When we do that, we have the absolute value of x is less than 9. Just like yesterday, it is time to set up 2 equations. Our first equation is exactly like it's up there with just dropping the absolute value sign, so you would have x is less than 9. With our second equation, just like yesterday, we're going to use the opposite of 9, which is negative 9. But here is something you have to know. When you are writing the second equation with the opposite, you have to flip the sign. So let's see what this says. This one says x is less than 9. So we have a circle dot at 9, and it's going less than that. This one says x is greater than negative 9. So at negative 9, it's going greater. So we know they're going to connect in a nest. Now, since it is less than, I'm going to show you a way you can write it in one equation. This only works when it is less than, not the greater than. So when writing the 2 equations, let's back up here. The first equation would be x is less than 9. We can write the second equation as part of this first one by writing over here another less than sign. So if you were to read this backwards, it says x is greater than, because you're reading this way, and then you put the opposite integer, negative 9. This reads the same. Let me rewrite that. So we have x is less than 9. X is greater than negative 9. This is exactly what the 2 separate equations said. It just says it in one equation, as indicated down here. So less is nest. So I'm going to solve less than equations with the one step. Okay, next example. This is not on your notes, but again, you look and notice that it is a less than sign. So I can write this in one equation instead of 2. First, we have to isolate the absolute value sign. It is already by itself, so we're ready to write our two equations. Our first equation, we just copy and paste x plus 4 is less than or equal to 2. To write the second equation, we can just add it to the left side of this one. We can say x is greater than or equal to, we're reading this way, so we just add another less than sign and we put the opposite of 2, which is negative 2. So we have the two equations, they're just written like this. Now, if you remember how to solve compound inequalities, when the middle, the x is not by itself, we have to get rid of the 4 in the middle. What you do to one part, you have to do to all three parts. So we are going to subtract 4 from the beginning, from the middle, and from the end. When we work that through, negative 2 and negative 4 is negative 6. We have the x in the middle, and we have a negative 2. So this reads x is less than or equal to negative 2, and x is greater than or equal to negative 6. But since it's less than, it's a nest. We can just graph it. We put our filled in dot at negative 6. We put our filled in dot at negative 2, and we connect it because it is a nest. Less is nest. Here's another example of a less than sign. The absolute value is not by itself. So the first thing we need to do is divide both sides by 2 so that we can get the absolute value by itself. Since this is a less than, we can write the two equations in one equation. First, I write x is less than or equal to 3. Then to write my second equation, I'm going to write it on this side with the opposite integer. X is already by itself. I've already finished. I know the range is from negative 3 to 3 with a filled in dot. So from negative 3 to 3, and it is a nest. Now let's look at the or side, the more, greater than, more than. With this, you are going to have to write the two separate equations, but we're still following the same steps. First step is always to get the absolute value by itself. So first we're going to add 20 to both sides of the equation. When we do that, we get the absolute value of x is greater than 7. Now we're going to write our two separate equations with an or in the middle. The first one, we just copy and paste. X is greater than 7. For the second equation, we know we're going to use the opposite of 7, which is negative 7. But when we write the equation with the opposite integer, we have to flip the sign. So x is greater than 7 or x is less than negative 7. So let's see how this would graph. It should graph as ors with the arrows going out. X is greater than 7. So we have 7 greater than. X is less than negative 7. So we have our ors going out. Okay, look at another example here. In this one, we have a greater than or a more. So we know we're going to have our two or statements. The absolute value is not by itself. So the first thing we need to do is isolate it. So we're going to subtract 5 on both sides. That gives us the absolute value of x minus 8 is greater than or equal to 6. We are now ready to set up our two equations. The first one, we just copy and paste. X minus 8 is greater than or equal to 6. Or when we write the second equation, x minus 8, we're going to flip the sign with the opposite integer. We have two one-step equations. So if we add 8 on both sides, on both equations, we'll see that x is greater than or equal to 14, or x is less than or equal to 2. So when we graph it, it graphs like this. 14 and 2. I think I did the opposite on that way. That's ors. More is ors. Here's an example of what an inequality would look like in a problem from the real world. As you read through it, you want to look for two numbers. One number is what we call your base number. The second number is going to be a number that tells you how much you're going to vary by. We're going to plug in those numbers into this equation right here. So a pediatrician recommends that a baby's bath water be 95 degrees Fahrenheit, but is acceptable for the temperature to vary from this amount by as much as 3 degrees Fahrenheit. Write and solve an absolute value inequality to find the range of acceptable temperatures. Now, if you were to just try to do this mentally and say, what could the range be? You could say, well, 3 less than 95 is 92, and then 3 greater than 95 is 98, so it would have to be from 92 to 98. But let's practice plugging in these numbers and showing what they would look like in an inequality. Our base number is 95. When you find that base number, you're going to plug it in right here. Notice that this is an opposite sign. So instead of 95 degrees, it's going to be x minus 95. And you're going to identify the number that tells you how much it varies, and that goes at the end. So when we write it, it doesn't matter what, I just use T for temperature, but you could use an X there. Minus 95, the opposite of your base temperature, is inside your absolute value. It's less, it's a nest because the solutions are in between the two numbers, forming a nest. And there's the 3 is the number it varies by. Now, as we learned, we are to write this. We write T minus 95 is less than or equal to 3. I can write my second equation by just adding it here to the other side. The T is not by itself in the middle, so I add 95 to all 3 parts. And when I do that, we got the answer that we thought we should, where the range of the temperature is between 92 and 98. Okay, let's look at another example. Again, you're looking for the base number and then how much it varies. A nutritionist recommends that an adult male consume 55 grams of fat per day. It is acceptable for the fat intake to differ from this amount by at most 25 grams. So again, we have our base number, which is 55. We're going to plug it in right here. And then we have how much it varies by, and we're going to plug it in right here. And we know that it's forming a nest because the acceptable grams of fat per day are going to be in between these two numbers. So when we plug it in, we're just going to say x minus 55, the opposite of that base number. We know it's a nest, and then we put how much it varies by. Now to solve this, we know it's less, so we write 2 equations. Here's the first equation. We just copy and paste. We can add the second equation here on the front with a negative 25. X is not by itself in the middle, so we add 55 to all 3 parts. And when we do that, we find out that the acceptable amounts are, let's do a little mental math here, 30 to 80. I think I did that right. 30 to 80, woohoo! This is not an example on your paper. So I hope that helps you with solving absolute value inequalities. Remember, less, you form a nest. You can write that as one equation if you want to. Or, more is or. You're going to have 2 separate equations, and the arrows are going to be like oars on a boat and go out.